Hey everybody, and welcome back to another video in the series, which is now I'm going to call the finale episode to this series because I want to call this episode as just marking the completion to this. However, it probably won't be the last video for this series because one of the things that I had been thinking about, especially when I mentioned it in yesterday's video, I believe, where I am definitely going to go over the motion matching nodes and stuff like that. I just got to do more research on those because I truly never done in-depth research with them. I've only done slight research in what they do just because I like playing around with motion matching. I think it's very cool technology. So I am going to do basically an add-on extra, like, you know, the beach episode for my animation blueprint, as well as doing beach episodes for the character blueprint series, because one of the things that I never did in that series was actually going over the traversal animations and stuff like that and putting that together. So I will definitely tack onto that. Though that was my first major series to YouTube, so you know, I was anxious, nervous, stuff like that. I still am, but I'm better at dealing with it now because I like seeing y'all, you know, be happy and stuff like that with the explanations that I tried to provide with this and get a better detailed understanding. I think that, you know, it's very heartwarming to me where it's like I'm actually aiding in other people. It makes me feel good, stuff like that. So I figured that I might as well tack on that stuff to that, but more kind of like at a later date because I am dying to get into your first 60 minutes of motion matching, you know, to show you how simple we can make GASP. Like, and I'm telling you, it's really simple, albeit there's some, you know, slight bugginess, some choppiness to it because we'll be dealing with like very basic sample set of animations and stuff like that from the Lyra starter project that we'll be utilizing because because they have a guide on, you know, the Epic Dev community and stuff like that, but it tells you what, like, you know, monkey see monkey do kind of thing, but it never gives you like the explanation or the why do it in this instance, stuff like that. So that's what I'm going to try to do for y'all is, you know, I want to go over that to put that together and then tack on videos after we put that together to try to overall make like a third-person shooter type game, stuff like that. So, you know, I'm dying to get into that, looking forward to that. So like I said, I'm going to be making these extra videos or whatnot and calling them like extra 1, 2, whatever for the animation blueprint and character blueprint series, but that'll just happen like here and there. So just be on the lookout for that whenever I do post them. But other than that, let's go ahead and get into this video, guys, and work on the last steering node because I do have more information about that, and it's actually interesting how they set up the steering, you know, details or settings and stuff like that. Because then afterwards, I do want to show y'all additional things that I have discovered, you know, within the game animation sample project that I feel dumb for, my oversight essentially on like, hey, I just never thought about checking here. So I want to show you all some things there, but then also have a discussion on kind of going forward with GASP, right? Because I did have an excellent question appear, you know, in the series introduction video that I kind of wanted to go over and discuss in person. So I do thank that person for bringing up that question, but for the moment, let's go ahead and get into the steering node. So as you can see, you know, from our previous video that we did set up the first steering node where, you know, we took a look at some of the nodes that are placed in here where, you know, I'm going to kind of gloss over the reset root transform node because like, since we've explained it a couple times, like in the first video of the motion matching series and then this previous one, I would like to think or assume that people understand why that's important to have in this, even if you are making a simple motion matching node. So basically it's just resetting your character's root transform. That's pretty much what it is. And then how we went over the get desired facing where, you know, it's calculating our target rotation or what we should be facing or rotating in the future by, I believe, 0.5 seconds is what the game animation sample project has it set to, and how it only works if we're either moving or traversing in the air. And then kind of where it's getting its current animation and the playback time and getting and passing it through in the steering so it properly orients, aligns, steers the character toward our predicted future spot, stuff like that. So that's essentially kind of like the brief rundown of what we did in the previous video. So now for the next one, we are going to let's go ahead and move this over and go ahead and discuss this. And I am going to discuss this and it's going to remain for future, days to come and whatnot, even though they say that this steering node is going to be removed in future releases. I can understand why. I believe there is a better method than using this. I just don't know what it is. But for the moment, let's just go ahead and get into it and discuss it, right? So let's go ahead and grab another steering node. If I can find it without being steering node, and it's going to be under our skeletal controls, just like in previously got. And now we have that. So then we need to make it look similar to how it looks in the game animation sample project. So we do need to undo the alpha, and we do need to, I believe, just undo the alpha. So you're going to click on it, and then we're going to look for our alpha. Or actually, no, I'm sorry. We don't need to get rid of alpha. We need to actually convert it to a bool, because we're going to be basing this off of tags from the current selected database, right? So let's go ahead and convert that. And then let's go ahead and start that off by grabbing the pieces that we need, right? So we're going to go down to our variables, and in the, I believe it's essential values, yes, where we are going to grab our current target database that we had set up. Then it's based off of our pose search database type, and then we are going to look for a get tags. So this one right here under variables database, we're going to look for get tags, and then out of tags we are going to pull out and look for contains, or it should be, oh no, this is right, yeah, I just don't know why it was contain item. For some reason I was thinking that contains was just contains, but no, it is contains items. So I messed myself up for a moment. But so what we're going to do is see if it contains the tag of turn in place, but make sure to spell it correctly as such. So there is camel casing, or semi camel casing. So if you've never heard of the term camel casing, if you ever start developing in C++ when you get better at game development, or if you move to another programming language, camel casing is essentially a way to properly set variables and other stuff with proper naming conventions, because in programming they don't like spaces, and sometimes underscores can be a bit too extra, but sometimes people like myself prefer to use underscores for spacings, just that way it remains as one whole word, rather than, kind of keeping the words together, in this instance, right, the turn in place. So if I do a camel casing for a variable name, right, let's do it based off of the other variables that we have on our left hand side, right? So if I go into this search, and this is just temporary, you don't have to copy me on this, it's just to show you the example of camel casing. So let's do has velocity, for example, right? So with camel casing, you would start the first word off as, small, where it's small, lowercase h, lowercase a, lowercase s, but then you would capitalize the V for the next letter and then finish it out. So that is essentially camel casing, or that's what it's calling, because think about it in the form of a camel, right? Where you have, remove the neck and head for the moment and focus on the camel's body for the moment, right? Where you have, the lowest part of, or not the lowest part technically, and I put that in quotes, but the low part of the camel's back, where it starts off small, but then it rises up due to the hump and then back down, to another low slope or whatever on the camel's back, to where it then goes into its tail and stuff like that. That's pretty much kind of what you need to envision with this. So where it's here's the beginning of, the camel's back, here's the V would be the hump of it, and then the rest of the camel would be the lower parts of the camel going toward the tail, right, where it goes back down. So that's what you kind of need to imagine when it comes to camel casing. It just looks cleaner in the form of programming and is useful to just like set variables as such. However, you don't have to do that. If you ever start, like I said, start programming in C++, you can do something like this where you can have has velocity and do the underscore just so that way you have what's called a pseudo spacing, but it remains as one whole word. So you got to make sure that it looks just like this for turn in place, because I'm going to show you where this is actually being retrieved from, because we do have another one for pivot. If you remember our previous functions that we've made, where we had the same reference, we had the same get tags and then contains, and then we looked for pivots. So I'm going to show you where those are in just a second, but for the moment, let's go ahead and take this and plug it up into the enabled, because what we're trying to define here is whether, you know, that our current database that we're using has the tag turn in place, because then if so, then you're going to operate this steering node, right? So then the next part with this, and I'm not going to put too many notes, I'm essentially going to copy and paste, because now that we went over this, it's like I didn't have any notes for it because, or any custom made notes, just because I felt like this was pretty simple to explain and get. So the next one we can do is we could, since we have the get desired node, we can just copy this note with the get desired facing node and bring it over here. And we can go ahead and do our facing return value here into the target orientation. I am curious why it is called facing and not... I never set it to return value. That's interesting, and I'm surprised that it actually accepted that. So let me go ahead and fix that real quick. That's actually hilarious. So let me fix that, because I'm surprised it let me make it a pure thread safe function without calling that return value, because every other time I do it, it screams at me. So we're going to plug get desired facing into the target orientation, because again, we want to look at our target, our desired facing in the future by 0.5 seconds in time. And then as far as the procedural target time, this is where I found pretty interesting. So in the game animation sample project, they have this bad boy listed at I think I saw multiple zeros at 1 million. Yeah, so it was like, you know, we got 1 and then 1 2 3 4 5 6.0. So we have that much. So let me pull up my notes and explain what I've discovered in regards to that, right? So why the steering is a procedural target time is set to 1 million. So what I've discovered is by basically setting the procedural target time to an unrealistically high value, the steering node effectively ignores procedural predictions during turn in place. Because one of the things that we gotta think about is that when it comes to steering and turning in place, and this is why I said I think I understand why they're removing this in the future releases, is because with turning in place, it's, you know, we're not going in a certain direction or doing any sort of rotations like while we're moving and stuff like that, you know, to where we need to have properly smoothed out. Like, this still helps, but we don't necessarily need it for our turn in place animations. It does help, don't get me wrong, but by, you know, essentially setting the procedural target time to 1 million seconds, which would be, I think I looked it up on Google, it was like 11 days or something like that, that we just effectively ignored this. So that's also another reason why, like, I don't know why, right? Like, that we're completely utilizing this and why I feel like there could be a better method. Because another thing too is that the steering node, you know, essentially relies on the fact that the database contains the turn in place tag. So, but in saying all that, you know, the main goal of the steering node, however, even if we set it to 1 million, is that, you know, without this node that we have, or this setting, the steering node might attempt to apply additional rotations based on, you know, the movements that we predict. So that could interfere with the intentional rotations that come with the turn in place animations, which could lead to jitteriness or conflicting motions. So that's pretty much, you know, why we're using it. But like I said, I feel like there could be a better method, just because if we're setting it to 1 million, it's just like kind of why, you know. So that's just kind of my thoughts on it. But yeah, so other than that, let's continue on with it. So let's go ahead and with the target time that we have on here, just like in the other steering node, let's go ahead and unbind it. So you're going to go to your setting on the node, and we're going to go to pin, and we're going to check off the expose as pin, because we're just trying to remove this check pin. So I forgot to tell you all that, for especially for beginners that don't know. When we check expose as pin, all we're doing is setting a check mark here to where it's either enabled or disabled. So right now, since we don't have a check, it's disabled. It's not disabled. All we did was we disabled it like from showing here and threw it in here instead, because it's not something we primarily need to focus on, or maybe we can just better set it in here. However, our target time in here is at 0.2 seconds, so that's how we're going to have it, right? Then the next thing that we're going to need to do is we are going to disable the steering below speed, because if you remember yesterday on how we set, or the previous video when we looked at steering and how we set it to 10, you know, we're trying to disable steering below a certain speed, right? However, in the game animation sample project for turn in places, is they have it set to -1, which I think just effectively disables it entirely, because anytime you set, you know, something in the settings or details in general, that if you place a -1 like modifier or -1 value, you either instantaneously do something, or you just like disable that functionality or that part of the function. So that's essentially what we're doing there, is because if we're turning in place, we're not moving, we're idle. Basically our speed is at 0. We're just turning around, you know, we're just turning in place. So once we got that, we're going to go ahead and grab these over here, because they also look for the current animation being played and the current playback time of the animation in play that's in question. And we're going to bring it over here, and we are going to plug in, and I'm going to move these around in just a second. We're going to plug in the anim asset to the current anim asset being played for the steering, and then the asset time for the current anim asset time within the steering node. So now with all that said and done, let me go ahead and move this around real quick, kind of like pretty it up somewhat so it doesn't look too disgusting, terrifying. Let me go ahead and move these down. I really hate that thing that just keeps spam popping up. I really don't know how to disable it. I've tried looking into it, but it's like it just you still kind of need it, so I don't want to completely disable it, but it really gets annoying when it's just like spam popping in and out, and it's just like, dude, come on. But other than that, we pretty much set up the last little bit of the steering. So I'm going to copy the dev note and put it in here, just like so. And all we have to do now is plug up this into here and this into the local 2 component, and then compile and save, and we are essentially done, guys, besides doing the motion matching stuff. So that's where I'm calling it. Like I said, I want to get into some other series and go over some stuff with y'all that I've discovered or researched. So essentially with this, we have now fully completed putting the game animation sample project together from scratch. So I'm hoping now that I've done the character blueprint series, which I really want to go through and redo all that. However, I kind of don't want to, because I think it's nice to see where I've started from and where I've come to now. But it kind of bothers me that people are like watching it, or especially new people that find my channel, and it makes me cringe, because I've been trying forever to fix my microphone settings to the point where I think it sounds good now for when I do my talks and whatnot, or my YouTube videos and a bunch of other stuff. But it just really makes me cringe to look back at that video and be like, oh my god. But other than that, we're essentially done. We've went through almost the entirety of the character blueprint for GASP, and we've essentially went through the entirety of the animation blueprint. So with that being said, let's do some discussions and do some look arounds for stuff that I've found out, right? So one of the things that I did discover, right? So with the turn in place database simp right here, or like the tags, right? So let me go ahead and pull up the game animation sample project over here so I can show you where I found it. Because like I said, it was an oversight on my part. I never gave it thought. I was always curious on where they found it, right? So let's take a look at the turn in places for the moment, right? So you'll see right here the stand turn in place. If we actually open the dense database up, you know, if you go down to where is it, you know, characters, UEF and mannequin, animations, motion matching data, database, dense, and then you look for the turn in place, you'll come to here. So what I originally thought in the beginning was when it said turn in place, right? So if I hover over the tab, I thought the name of the database needed to be turn in place, and then it just got some sort of tag. I couldn't have been further from the truth, because after playing around with it today or whatever, just because I was like, where could this thing be? It's right here. Right here, you'll see it, turn in place. I feel so dumb overlooking that, especially with the amount of times I've put motion matching databases together, because it's such a fascinating technology to me. I love it more than state machines, but I also love the simplicity of state machines, my God. So here it is, turn in place, right? So if we close out of it and we go and let's look for pivots right here, the stand walk pivots. I love how it opens up on my other screen. If we scroll down here, we don't, surprisingly, I'm shocked that we don't have a pivots one, because we have a walk pivot. So let me see, where is the run pivots then? I have to check. So run pivots. So the run pivots have it, but shockingly, so I guess I found an error. I guess I found something that just wasn't done, which, don't worry, Epic Games, I still love you for coming out with this project, but so far I think I've discovered 2 issues where I remember finding a misspelling in one of your things, or one of the nodes. I think it was orientation warping, if I remember correctly. Let me see, it was... yeah, compensate, as you can see, compensate. Yeah, so found that, and then I guess in the walk pivots, we don't have a tag. So we definitely do need to change that to pivots, so that way when our animation database, I believe, where was it? I believe it was it in here? I believe, oh God, I don't even remember where we used the pivot. So I think it was in one of the functions, now that I think about it. Shoot, it's definitely not in trajectory. It's not in here. It's in one of the movement. Oh yeah, is pivot. No, wait, is not pivoting. Oh, is starting. It's gonna be in a starting. So right here, right? Because we have walk starts and we have run starts, right? So if the walk pivots, you know, don't have that pivot tag, I feel like then the is starting could have a potential bug if we don't put that tag in there. So that's why I went ahead and put the pivots in there, now that I've actually discovered that that's missing. So unless that was intentional, I don't know. But if it was intentional, I don't know why they did it like that. But as far as I'm aware of, pivots need to have that pivot tag, because now that we've been through this, you know, we want to make sure that for is starting functions that we want to get the walk starts, because pivots and starts, with how they set up the functionality, start eerily similar. So if you look at the is pivoting, we get future velocity and the current velocity. We get the local rotation from our X vector from it, and then we look at the change of that rotation and then convert it into the absolute, to where then we return like our degree variables here in the orient to movement and strafe, right? So it's pretty much more or less like this that I'm worried about, because they do a little bit similar here. However, what it's trying to do is kind of compare vector lengths. But if you were to throw the math in kind of to, like, you know, to somewhere, or do some like research on the math, they kind of go hand in hand with how it, because technically when you're pivoting, you're starting back up by going in the other direction. So you can technically classify it as an is starting. So you have to be careful of that. So that's why it is important that you probably should, all of us should go through the databases to make sure they have proper tags in place, like pivots, more pivots, turn in places, loops, stuff like that. Not, even though there's no other database tags that we need to be wary of, but in case in the future, if y'all ever update your functionality for any of these for whatever reason, like when we go in the event graph and look at our essentials value, whatever current database is being selected by our node context or our motion matching node is going to get applied into here, and it's going to get the tags and it's going to store them in here. So currently in here, we so far have that I have seen are turn in places and pivots. I don't know if, let me see, does Land's Light have anything? Land's Light does not, but what you could probably do is give it a tag just in case you ever do functionality for this in the future of Land's Light, or maybe, not like that. So probably like this, Land's Light, just so you can differentiate it in case, like I said, in case you ever have, get the, the more advanced mindset or, capabilities of adding your own functionality to this, and you want to do something in particular, this is what you're going to have to do. So, however, I'm not going to save that because I'm not too worried about that kind of change, but just in case that, that's what you want to ensure that you have is proper tags for that. Believe it or not, I still have not found where this is at, or like why we're using the integer rather than float when the chooser table is calling it as a float. I've still not found that. I am bamboozled, flabbergasted, whatever you can name, in regards to why I cannot find that. So I want to apologize to you guys for, some of the things that I have not been able to find. It's just that like I've said in multiple videos already that I'm only like a few, like 3+ months learned of UE5 and stuff like that. So I don't quite know in depth everything, or as stuff about the Unreal Engine, on where you can find stuff in animations, motion matching, etc. It's just I'm just doing a bunch of the reverse engineering, which helps teach me better stuff, right? So that's essentially what I'm doing, because so whatever I reverse engineer, I want to try to provide to y'all, in terms for y'all to understand, because I want to provide, again, that newbie explanation for what is going on in here, and try to help relate to what y'all might know in order for you to better understand how it works. Because believe it or not, since I have done this series, I've done the character blueprint and the animation blueprint, I cannot tell you how many new projects I've started from the third-person blueprint and have actually incorporated, the well-optimized functionality from GASP into the third-person template. Like, that's why I am actually excited to show y'all your first 60 minutes of motion matching, because we are going to be basing everything off of the third-person template with like very minor changes to what they have, right? Like in the animation sample, or in the animation blueprint of the third-person template. We're going to be a couple things that we do remove, like the should move, because we're going to make pure functions, our own pure function for is moving, right? Because I want to show you how simple we can make this. And I keep stressing how the simple part, because I think I mentioned earlier in the video that I was actually asked a very great question earlier in my introductory series to the Anim Blueprint, by another fellow YouTuber. If you check out that video, I'm pretty sure you can find the comment. Sorry guys, I got into like a huge tuft of air, like air, not hair, and just like I needed a cough real quick. But he asked a good question on people stating that the game animation sample project is not a very good project, or it's not well optimized for being able to build a game, right? And he, she, you know, or, you know, I'm sorry if I misclassed your gender and stuff like that, but, you know, what the YouTuber had said was they want to build a large scale game and they just heard it wasn't well optimized. Well, I'll say this, with all the people that have followed along with me with this tutorial series and the character blueprint tutorial series, and how I've uncovered and researched and explained what's going on at every section and every step of the way, or as much as I could, that even in the game animation sample product page on what is currently now Fab, it explains that this is set up with the best practices of the gaming industry, especially amongst AAA gaming studios, right? So, however, what they also stated was, I believe they also stated that this is purely blueprint, a blueprint project. Like I can't remember if they stated if they used any C++ at all, but that's the thing that's crazy, is if I remember that correctly, this is very well optimized for a blueprint only project that they have given you, right? So literally they've given you a AAA game right out of the box. You can definitely make your game with it. However, there's a few things to consider now that we've, like, you know, went over this research together, right? Where I've stated to the person, you know, what my thoughts are on this, or what comes to mind of why people say it's poorly optimized. One thing for certain, 500 plus animations, that's gonna bog down your system. I'm pretty sure a lot of y'all have been onto Mixamo and other stuff, and how you've seen how to get, you know, the FBX files from places and animations and stuff like that. Hell, like, I'm pretty sure you've been onto the, you know, the OG Marketplace or Fab Now, and when you look at animation packs, you know, I'm pretty sure there's a data file size on there, and, you know, with 500 plus animations, especially that have to be animated, where it has to go through this pipeline with every single animation that is being played, it is gonna bog down the game. On top of that, you're trying to simulate a video game in a viewport editor, right? So not only is the editor eating up resources like more than Google Chrome on your computer, it also has to run all these mathematical calculations that we have, you know, within our functions. It's got to then do motion matching predictions and checks and stuff like that. So basically it's almost like its own pseudo AI machine learning process, where it's like, okay, what did we do with the past 30 animations? Okay, predict the next 15 and do X, Y, and Z, right? On top of that, you know, we just sat there and looked at the motion matching node, where we have procedural target times where it's trying to guess our stuff 0.2 seconds ahead, like every frame. We're trying to get desired facing, where it's trying to get our trajectory sample at every 0.5 seconds. So like we're running all sorts of stuff that is constantly having to do checks into the future and predict our movements, get the proper animations and stuff like that. It has to sift through, as you can see in the content drawer, we have 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19, 20, 21, 22, 23, almost 24, you know, because if you do 8 times 3, it's 24. We have 23, almost 24 databases right here with, you know, animations, you know, in each one of them, with their own settings of whether they're looping or if they have root motion enabled, mirroring, and then reselection of the node, stuff like that. And then when you look at how the chooser tables are, so if we go back and look at, not the database table, chooser, we want the dense one, right? This looks simple enough, but with every animation, it also has to go through this, and then once it chooses the proper, you know, nested chooser, then it's got to go into that chooser and pick out the proper database. Then once it picks out the proper database based off of our actions, it then has to go into the database and pick out the most appropriate action based off of other parameters that are set. So that's why I'm going to do probably a motion matching series playlist on its own. I don't know if I'm going to tack on to the animation blueprint, where we're going to discuss like schemas, databases, pose count biases, looping cost biases, you know, because these are actually pretty interesting from the basic examples that I got in your first 60 minutes of motion matching. So we need to go over all this, but it's also doing these calculations. Like, it's crazy the amount of calculations and stuff it has to do, as well as hold up your entire viewport editor, right? So it's cool, it's fascinating. I can almost say I'm probably confident, or actually I am pretty confident, because of how well optimized this is with blueprints only, that once you actually build the game, like what I would suggest doing is, before you tack on all your scope creep ideas, because trust me, I want to add a bunch of stuff to this too, it's just for testing purposes, what I'd recommend doing is probably, since they give you a AAA game character straight out the gate with no programming on your end, I would almost say learn level designing and world building first. Like, make a basic map, add trees, add grass, add bushes, add butterflies, add, you know, sparkles in the air, add a dynamic sky, something like that. Like, learn how to do those from like other world designing people, and then just throw your character in, like migrate your character assets in, and then what you should do is then just build the game, right? I believe it would be under tools. I gotta find it, but there is a build button, I believe. Oh, right here. I had to go to default level. Yeah, and then just build the game. So definitely looking at how to do that. I believe it's right here, like build and submit. But essentially too, what it's going to happen when you build, from my understanding, from what I've seen in like half-assed research when I've, you know, was trying to look at building games, is that building, when you finally package and build your game, it's gonna, it tries to like quote unquote optimize your game, right? So it's going to like remove all this like editor junk. It's going to remove all the stuff that you no longer need in the game because you're now packaging it and building it. So not only are we going to stop eating resources from the editor, we then take out like the other parts that the editor has to then do to like maintain and simulate your game when you are developing. So when you throw all that stuff out and you finally build and optimize your game, it should work like a proper game. Like, I want to say it's going to focus and play on par with like Grand Theft Auto 5, Cyberpunk, maybe No Man's Sky I would consider now. Yeah, probably AAA. Yeah, I'd probably consider No Man's Sky that. You know, and a bunch of other like big games that are huge, right? So, you know, there's just a bunch of stuff that's going into this right now to where it's like, probably if you want to have an even better experience, I would highly recommend probably toning down the 500 animations. Probably look for simple puts of steerings and orientation warping, stuff like that. Kind of like minimize like your trajectory history count, stuff like that. You know, kind of look over them and just see if there's any ways to optimize them now that we have more information. Because like I said, within the year first 60 minutes, I hella optimized this with just simple stuff. So I can only imagine, you know, what more I can do if I start tacking on more of this stuff, but at like a simple, but adding simple processes. Because like literally when we look at the, you know, is starting, right? I'm not even doing all of this, right? I do need to add this now, because now that I do have a better understanding of where this is being applied to and what they're getting, I will be adding this into the 60 minutes of motion matching to make things simpler. But basically with like an is pivoting, I use, you know, acceleration for instead of future velocity, and I use a dot product on it with velocity, where if you're not familiar with what a dot product is, I've spoken about it in a couple of my videos, where basically you're checking to see if the velocity acceleration aligns with the velocity and if they're going along the same path, right? So if you suddenly decide to start this, so if you normalize those values to where they output 1 rather than, you know, an acceleration of 1500, a velocity of whatever, right? You know, so if you normalize those values to be either 0 or 1 by using the normalize node, then what it's going to do is check to see like, okay, are both of these 1? That means we're going along the same path, whether they're both going forward, backward, left, right, like whatever. But then as soon as the acceleration takes a different turn, like say a turn left, I start accelerating to the left, but my velocity hasn't caught up with me yet. Then we enter a 0 motion because we're going perpendicular now. We're not going against velocity with acceleration. So when we eventually, like say if we're going forward and then we finally decide to cut and turn backward and we start accelerating backward, then we're finally going against our velocity, at which point was going forward, and then we generate a negative number. And so when we encounter that negative number, we can classify that as pivoting. So, you know, stuff like that. So we'll be looking over much simpler stuff. And so then like for the is moving, right? Like as long as we have acceleration and our, you know, velocity or our ground speed is greater than like a certain number, we're technically moving, right? Or for starting, if we have acceleration, but our ground speed or velocity is less than a certain number, we're starting. You know, it goes fairly simple, but this, even with how simple I'm going to make it for y'all, it's not going to cut it anywhere near what Game Animation Sample Project does, because this is more advanced stuff where it's trying to get more precise calculations in order to smooth out your animations, play it, have a smooth, enjoyable gaming experience with your character, stuff like that, right? So that's another thing. With it trying to smooth all these animations out, we're going to be bogging down the game, right? So I feel like if you were to just cut the animations in half somewhere, or just have, you know, cut them down to a point where like you have like 5 databases maybe that have like 8 directional movements to where you at least account for every direction you can move in, I think you'll probably turn out all right with it. That's just my opinion, or at least my take on it. So definitely take it with a grain of salt. But as far as for someone that's actually researched and provided y'all with the information of the Game Animation Sample Project, I just want to kind of give my take on it. But other than that, thank you Epic Games for providing this sweet ass project. I think it's really cool, very well optimized with Blueprint only. I can only imagine how further optimized you can actually make this if I actually decided to pick up C++, but I will be damned if I pick up C++. I do not want to go back to it. I'm trying to hold off as much as I can until it forces my hand. But other than that, guys, that's what I wanted to show you, and or at least show and discuss with you and give my take on this, stuff like that. So now, as far as future videos, like I've been stating, I will probably make a separate playlist where we do GASP. I'll probably call it something like GASP post search from scratch, something like that, whatever clever name I can come up with it, where we'll go over strictly all of the motion matching settings, how you should set up stuff, where we're going to need normalization sets, post search schemas, post search databases, setting up the chooser tables and stuff like that, and going over all the settings for those. However, I'm kind of dreading those at the moment, because it's like I want to finally take a break from this and get into some other stuff, because like I've shown you guys the other day, I finally got Combat Fury. I want to start studying that, so that way we can do a from scratch from there, or at least an outlook or an overview of that, how, you know, implement it into the Game Animation Sample Project. If you haven't seen it already, Clyde definitely has, you know, awesome video where he puts together the integration for the game, for Combat Fury into Game Animation Sample Project, where basically Clyde, if you're watching and listening to this, I will be watching you do that. I will be copying it down. However, I am going to take my own notes and do my research on it, so I appreciate you having those videos. So, but yeah, I will do that. But I'll probably put up a vote for you guys, because I want to see if you just want me to respect the developer and just discuss the Combat Fury and the stuff I research, or if we want to create it from scratch. Because if we decide to create it from scratch, then I feel like we disrespect the creator in a way, to where it's like, well, if we create it from scratch, than for someone who put together such an awesome project that we kind of disrespect them in a way. And as much as I want to give that information out for free, I feel like he deserves the money for such an awesome effort and work that he put together for that project. So I will leave that up to you guys, like in a voting poll, where it's like, should we do a Combat Fury from scratch, or do we just do an overview of the series to try to get a better understanding of just how it works within the project, as well as making whatever adjustments we should, try to make in there, like adding more ability pools, maybe seeing if we can do like branch trees and stuff like that. I would definitely love to look into something like that and whatnot. But also too, it's going to take me some time to research that. I at least need to get started and kind of poke and prod around it to see what's going on, so I can get a couple videos going for you guys to at least, give you something. But other than that, I'm going to be focusing on the your 60 minutes of motion matching, and I'm going to be doing a Pong tutorial behind the scenes to just push that out. And then I'll also do some other videos, guys, where I want to go over some free plugins for you guys that I found to be really cool and probably very useful. I just got to do some testing on those, so be on the lookout for those kind of videos as well. So they'll be popping in and out here and there. So other than that, guys, I hope you enjoyed it. I'm calling it my finale. I hope all this was educational for y'all. And if it was, I would greatly appreciate it if y'all would, check out my other videos in case you haven't, and look forward to my future videos to come. But other than that, guys, my fellow dev team, y'all have been great. Y'all have been excellent. I greatly appreciate y'all tuning into this series and the previous series with me, guys. So other than that, y'all have a great rest of your day and take care.